Hi, today we're going to go over notes 2, which deals with variables on both sides. But before we get into that, I kind of want to go over a few things that I've been seeing on on the assignment 1 when working with variables on one side, combining like terms. So if you look at letter A, the problem is 4x minus 8 plus 3x equals 13. You see that the 4x and 3x have a v above it. So that means variable terms, and then we have our constant. So we can combine the variable terms. So 4x and 3x is 7x, minus 8 is 13. Now then, I'm not going to finish solving it. I'm just showing you some places where I've been seeing some errors. The incorrect steps, same problem, 4x minus 8 plus 3x equals 13, is I'm getting some people, instead of combining the like terms first, they're trying to take one of the variable terms and subtract it from the other and on the same side. So I have a thumbs down and it says never do on the same side of the equal sign. So never do that on the same side. Let's go ahead and take a look at one on letter B, where everything that needs combined is on the right side of the equal sign. So we have 10 equals 6 plus 9x minus 7. So the correct way is to combine the constants. I have a C above those. So there's 2 of them. So 6 minus 7. Remember the song I was singing the other day, that's to the tune of Row, Row Your Boat. Same sign, add and keep, different signs subtract. Take the sign of the higher, then you'll be exact. So 6 minus 7 is 1. The sign of the larger number 7, it's a minus. So you have 9x minus 1 on the right side. What I'm seeing some of you do is trying to subtract 6 from the same side. So if you see the incorrect steps there, that is the wrong thing to do. You need to combine like terms. So I just wanted to point that out before we get into variables on both sides. So now let's go ahead and take a look. It says sometimes our variable terms are on opposite sides of the equal sign. So we have to move one of them to the other side. For example, on problem 1, I've got 6x minus 9 equals 2x plus 15. So what we could do, since we're balanced, I've got the 6x is a variable term, and I've got the c is a constant for your negative 9, and then on the other side, 2x is a variable term, there's a v, and then 15 is your constant, and there's a c. So since I'm balanced, I can basically do anything. So I'm just going to say, let's go ahead and cancel out the negative 9. So the inverse of a negative 9 would be a positive 9 right here. And whatever you do to one side, you do to the other. I'm going to draw this out. This will cancel out. So I'm going to bring down my 6x equals 2x plus 15 plus 9 is 24. Now then, this is going to look a little bit different because I do have a variable term on the left, which is your 6x, but then look on the right side. I also have a variable term there. So what I need to do is to get that 2x over here with the 6x. So the inverse of a positive 2x would be a negative 2x, and whatever I do to one side, I do to the other. So that cancels out. So 6x minus 2x is 4x equals 24. And then I divide both sides by 4. So 24 divided by 4 is 6. Let's look over here at problem 2. It's the same problem, but instead of canceling out the negative 9, I'm going to cancel out the 2x. And I told you that you could do anything since you're balanced. So to cancel out the 2x, I'm going to go minus 2x, minus 2x. So those cancel out. So 6 minus 2x is 4x. Minus 9 equals 15. And then I have a variable term, a constant, and a constant. So this is just like solving the 2-step from notes 1. I'm going to add 9 to both sides. So I get 4x equals 15 and 9 is 24. Divide by 4. And our x is 6 once again. So 1 and 2 are the same problems. I just work them a little bit differently. And it does not matter which way you decide to work it out. As long as they're balanced, you can pretty much just do anything. Let's take a look at number 3. Now, on number 3, I started it for you. So it says, finish solving the following problems. The first step has been started for you. So I'm going to draw my line down through the equal sign so you can see a left side and a right side of the equal sign. So I'm going to subtract 2x from both sides. So those will cancel out. So 3 minus 2x is just x. Bring down your 8 equals 13. All right, so I've got this variable term right there, my x. I've got a constant and a constant. So I'm going to subtract 8 from both sides. So 13 minus 8 is 5. All right, let's look at number 4. So number 4, I decided to add 10 first. So those will cancel out. I have negative 7a equals 20 plus 10 is 30 minus 2a. All right, so I've got a variable term here on the left, and then I've got a constant right here, and then I've got a variable term here. So I need to get this negative 2a over here to the other side. So the inverse of a negative 2a would be a positive 2a. Whatever I do to one side, I do to the other. So negative 7 plus 2. So here's that song again. You're probably tired of it, but this is real helpful when you get to the end of the year and you're not needing a calculator because you can kind of remember this. It's very helpful. So same signs, add and keep, different signs, subtract. So 2 from 7 gives 5. Take the sign of the higher. The higher is your negative. Then you'll be exact. And then I divide both sides by negative 5. All right, so we have 30 divided by negative 5 is negative 6. And there you have that. All right, let's go over here on the back side. It says, would the step that is in bold be the most effective, correct first step? Write yes or no in the box. Remember, never leave nothing on one side. All right, so here I've got a variable term. I've got a variable term, I've got a constant, and I've got a variable term. So here's where my left side and right side of the equation are. So if I add 6x to both sides, what's going to happen over here on the left? Well, you're right. It's going to cancel out. So the thing here says never leave nothing on one side, and that's what would happen here. Okay? So this would be no. Let's look at problem 6. So I've got a constant, a variable term, and a variable term. Here's my equal sign. So I see that my V's are the same, so I need to combine them, but they need to be on opposite sides of the C. We're going to leave that C there. So I can subtract 15W, which cancels out, and bring it over here. So this is looking 9W minus 15W would be negative 6W. Okay, so this is working out good. So this would be a yes. So then on number 7 and 8, it said try these on your own. So when we do this here, remember that this is what divides our equation in two. So we're going to combine 4x and 2x gives you 6x plus 2 equals 3x minus 22. Now, we are balanced on both sides. We have a variable term and a constant. We have a variable term and a constant right there. So these are variable terms and those are constants right there. So it doesn't matter what we do. You know how I told you on notes 1, I like to get the variables on the left. So that's what I'm going to move first. So I'm going to subtract 3x from both sides first. So that cancels out. So 6 minus 3x is 3x plus 2 equals negative 22. And then it's just a regular two-step equation because I have two constant terms. So I'm going to subtract 2 from both sides. I get 3x equals same signs, add, and keep the common sign. And then I divide by 3. So my x is equal to negative 8. All right, let's take a look at number 8. So here I've got a distributor of a fraction. So this is easy. It's a half. So half of 2 is 1 minus half of 4 is 2 minus 2x equals 13. So we're going to combine negative 2x and negative 2x. Same signs. Add and keep the sign. Bring down your 1. Okay, and then I've got, here's my dividing bar. I've got 1 minus 4x equals 13. So this is a constant. That's a variable term. That's a constant. So let's get our constant away from the variable term. So we're going to subtract 1. So we have negative 4x equals 12. Divide both sides by negative 4. And x equals 12 divided by negative 4 is negative 3. The last thing we're going to cover are some specials. Specials are when variables or constants drop out. So for instance, x plus 4 equals x plus 4. If I subtract x from both sides, minus x, they would cancel out and I'd be left with 4 equals 4. I could also subtract 4 from both sides. So I could go minus 4, cancels, cancels. So I would be left with x equals x. I could also go even further and even subtract x from both sides. So they would also cancel out. So I'd be left with 0 equals 0. So if the left side of the equation is equal to the right side after you perform a first step, then it's true. Is 4 equal to 4? Yes. Is x equal to x? Yes. Is 0 equal to 0? Yes. So this would be all real numbers. So all real numbers would work no matter what you would put in there. So all real numbers, or a fancy way you can write an R like that for all real numbers. Another thing that I do sometimes is just do A-R-N for all real numbers. That's just a little way of doing that. So let's take a look over here at, so this is true. So if the left side is equal to the right side, it's true, which means all real numbers. Over here, if the variables or constants drop out, but it's false, so let's say that I subtract my x's from both sides. So they would both cancel out. So I'd have 4 equals 3. Is 4 equal to 3? No, it is not. It's false. If I did, let's say I subtracted 3 from both sides. And then I had, let's do this over here, x plus 1, and I got 1 from 4 minus 3 equals x. And then I would subtract this x here and this x there, and my x's cancel. So I'd have 1 equals 0. That's how I get this right here by doing a little more work. 1 is not equal to 0. 4 is not equal to 3. So whatever you do, whichever term you subtract first, If it ends up being false, nothing can work. So that means any number that you put in place of x will not allow the left side of the equation to be equal to the right side. So therefore, this is no solution, or it's a circle with a line through it, or you can always write NS. So let's take a look at 9 and 10 and see if which one's going to be all real numbers, which one's going to be no solution, or maybe there's two of one of them. So the first thing we need to do is hippity hoppity here. All right, let me move this screen up just a little bit. All right. So I've got 3x plus 8 equals half of 6x is 3x, and half of -2 is -1. So look what will happen. If I subtract my 3x from both sides, here and here, is 8 equal to -1? No, it is not. So therefore it is no solution. Or you could do a circle like that. All right, let's see what happens with number 10. Here is our equal sign. So we're going to combine 1x minus 4x. Same signs, add and keep. Different signs, subtract. So 1 minus 4 is 3. The larger numbered sign is a negative. Plus 6 equals, and here we're going to hippity hoppity, distributive property. So this will be -3x. -3, don't forget, that is a -2. So -3 times -2 is +6. So we could actually stop here because you have the same thing on the left as you do on the right. If I didn't recognize that, and you were to go, oh, let's see, I'm going to add 3x to both sides. Oh, but I see they cancel out. So then I have, is 6 equal to 6? Yes, it is. So therefore, it is all real numbers. Or you can do I'm not real good at this, but something like this. Boom, boom. Something like that. Like I say, I'm not the best at that at all. Close it in, so it looks something like that. Some of you are much more artistically inclined than what Miss Bean is. Thank you.